Y383712, I need you to explain this patch you've been working on.
Of course. Our auditory perception is one of our most powerful senses. So why is it that we normally only represent data with graphs, pie charts, and other visual means when our hearing can be more useful at picking up on certain patterns?
Our hearing could be more useful?
Sometimes. That's where sonification comes in.
Sonification?
Sonification is the portrayal of information or data through the use of non-dialogue audio. It can be used to help convey something that a visual medium like a graph might not be able to. An early example of applied sonification is the Geiger counter.
The device that measures radiation.
Right. As well as its dial display, it emits a distinct clicking sound to indicate the level of radiation in the area, which enhanced its usefulness not only as a measuring device but as a safety device as well. The user's attention could be taken away from the visual display while working in a hazardous area, but because the clicking gets more frequent the more radiation there is, the user is alerted to the threat immediately. There are certain things you're more likely to pick up on while listening rather than looking. Sonification can make it easier to avoid inaccurate perceptions of data such as spurious correlation.
Spurious correlation?
That's when multiple sets of data look like they're proportional to one another, when in fact they're probably not. I decided to apply sonification to a set of data in an area that made sense for an audio project. Music. I found the sales figures in millions of dollars for music formats in the United States between the years of 1973 and 2016. I copied the values into 4 notepad files, one for each format, and then integrated those into this patch. The sound you're hearing right now is a combination of 4 sounds, one representing each music format. Their volumes in relation to one another are representative of the sales in millions of dollars for that year. So if, for example, the cassette hiss is much louder than the vinyl crackle, that means that cassettes sold much more than vinyl in that year. Next, I'll just explain the parameters you can change, which are controlled by send signals sent from the sliders into number 2 objects within the main patch. By default, the patch cycles through the years 1973 through 2016, but you can change the start and end years with these sliders. You can also change the rate at which the patch cycles through the years. You can set the master volume for each sound if you just want to focus on one or two. There are also filters on the tape and CD sound to help differentiate between the two if you're having trouble. The sound representing online downloads is actually created with an onboard FM synthesizer. You can control the pitch, modulation frequencies, and the amount of modulation using these sliders on the interface. By now you've probably noticed that little ticking sound. That's an indicator that a decade has passed within the time frame of the patch. You can turn off this sound by using the volume slider on the patch. Now to look at the inner workings. The patch cycles through years by adding to a float value which is defined by the user on the interface. A spigot object creates a logic system that stops that number being added to when it reaches the value corresponding to the user's chosen end year. The float value is sent to various places in the patch, most prominently these sound generation subpatches. When the patch is loaded, a message box sends values to 2 arrays within the subpatch. One array is based on a series of numbers put into a text file, which are the sales figures of the musical formats. The second array loads in data from an audio file representing that format. The distinctive crackles and pops of an old vinyl record, the noisy hiss of a cassette tape, the sound of a CD drive working, for obviously playing a CD, and then the onboard synthesizer, representing online downloads. Every time the float value increases, the corresponding point on the array for sales in that musical format is red. This number is then multiplied by the amplitude of the sample being played. This amplitude is divided by 1000 for the sake of volume, and in the case of the CD and cassette sounds, put through a bandpass filter. The principle is exactly the same for the synthesizer, only it's the amplitude of the wave created when all 3 waves are summed together that's being controlled instead. The last thing to explain is simply the decade chime. I decided to add this sound to make it a bit more obvious when a decade had passed within the time frame of the patch. Implementing this was very simple. All I had to do was implement another logic circuit that would send a bang to a message box telling it to play the sound from an array. This would happen whenever the float value equaled something ending in 7. But, for whatever reason, the final value is actually 36. To this day, I have no idea why this is the case.
So apart from that sneaky 36, it's all good.
Yes, I'd say so.
I still don't get the purpose of turning this data into sound. Was your patch even good?
Well, I think the data as sound actually illustrates the fact that a new musical format will always dominate the one prior to it.
Yeah, I guess you can really hear that, especially with that CD drive noise. Oof.
Although I do wish I'd given the user more control over the sounds.
Yeah, so they could extrapolate more than just a general idea. I gotcha.
Anyway, I've gotta go.
Oh yeah, the deadline's like tomorrow, lol.